Hi, my name is Bobby Harrell. I'm the Business Development Manager for Strand and Verilight, concentrating on systems. So I primarily interface with specifiers, consultants, engineers, distributors. I work with the sales team to help with the specification side of the business. A lot of the reason for this particular topic came out of my visits to job sites at the commissioning stage. When I would go in to do training, in user training on the lighting control, and finding that a lot of questions were being asked right at the commissioning that had a direct impact on the design of the facility. So as I started peeling back the layers, I started to get a better understanding that as we've moved from a lamp-based lighting system to an LED-based lighting system, there were a lot of components and specifics of this technology that wasn't necessarily be taken into account um, when it should. So that's where this came from. So in order to provide a complete specification for a theatrical space, one needs to understand what the function or the programming of the space is going to do. And when I say programming of the space, I mean from the producer's perspective, what types of events are going to happen in that space? Who are the clients, right? What are the needs of the space and how must it respond technically in order to provide that? So this process needs to be addressed regardless of whether this is an elementary school cafetorium, middle school auditorium, high school proscenium or black box, university, house of worship, performing arts center, really any facility that is requiring a typical theatrical control and architectural control based system. So some of the information that I'll present today are tables that where I have filled these out just with typical information as an example. I think the goal would be that anyone who's dealing with the design, the lighting design of a space would want to fill this information out to really sort of come up with a better understanding of what's needed for the system. So one of the first things is to go through and have a table listing the functions. So again, this is a typical school list. So the first thing would be an assembly. And then you identify where this function is going to take place. Well, it's going to take place on the stage as well as the apron. So that starts to tell us that we're going to need lighting for the apron as well as the stage. And again, this is making the assumption of based upon what I've seen with a lot of typical school systems where there is a reasonable enough apron that gives the students and actors and performers or presenters an acting area that is in addition to the proscenium side of the stage. So additional functions, choir. So where are they performing? They're going to be performing on stage with the apron. Is there a pit? I know there's a lot of schools where they'll put choir on risers in the pit. Not every school is going to have a pit and a space to do that, but a lot will. Same thing with the band, right? Where are they going to perform? And orchestra. And if you're doing a play or a musical, what are the locations? Dance recital. Some schools use their performing space as classrooms, others don't. Do you have a projector? Do you do moving night? Do you have things that are specific for for that projection that you do. So coming up that list, identifying the locations, and that's going to start help us lay the groundwork for knowing where to go next. So the next topic would be dimming and power. So with a new space, current day technology, it's certainly much more cost effective to provide an LED based system than a lamp dimmer based system. The fixtures are more expensive at the beginning, but the infrastructure that is required for LEDs is much simpler, and the installation cost is also less than with a traditional dimmer based system. The auditorium will no longer require a separate climate controlled maintenance room where the dimmers would be located. It no longer needs a K-rated transformer, and we have many dimming and relay solutions where they can these are panels that can be installed directly on the stage wall. The A21 and the contact racks are convection cooled, and therefore they do not need the physical considerations that one would need with a traditional dimmer rack based system. We also have a completely different solution, and that would be distributed dimming. So one could choose the R21 raceways, and these can provide custom configured relay data powered and data distribution raceways, and at that point there won't be a need for any relay cabinets to be mounted anywhere, because everything is going to be directly in the raceway. So thinking just for a moment about control, a school auditorium will typically need 24/7 lighting control using an architectural control system, and then more specialized control can be used for the theatrical performance with a theatrical console. The other thing that's important to understand is the school's need for snapshotting, and this is the ability for the end user to be able to set up a look with house lights and with stage lights, and be able to capture that look. Some people might call it what you see is what you get, where you capture that and store it onto an architectural preset. In the very recent past, I have continued to see snapshotting specifications that call for snapshotting of house lights only, and not including the stage environment. And that's definitely something that we recommend that gets corrected, because I always find that every end user wants to be able to capture an entire stage snapshot and store it on an architectural preset. My preference for setting up an educational theater's facility is to start with the premise that 80% of all events that occur within that space can be provided lighting through the architectural control system. That in most cases, the only time that the theatrical console is going to be needed is during scripted environments like plays, musicals, dance performances, and in setting up the looks for the snapshotting. The majority of all other performance types will likely be able to be served with the architectural system. And when I talk to the end users about that, they generally and immediately become very relieved, because activating playback on an architectural control system is far less complicated than recording content for much more involved theatrical scripted productions. So let's talk about architectural control. Strand's vision that architectural control can provide comprehensive coverage and control of any performance system using extremely scalable solutions of expanding components. The components are combinations of touchscreens, button stations, and slider stations. So we have our new offering of touchscreens is a 10-inch touchscreen. This can be surface mounted, flush mounted. It can be mounted into an equipment rack. It could be mounted into a portable station. We generally find that systems, a typical school auditorium will likely have a 10-inch touchscreen backstage. It could be an equipment rack. It could be mounted directly to the wall. There likely will be one in the front of house booth or a portable station that can be moved to different locations. Could be used on the podium, could be used in the booth, but that will give the space quite a bit of flexibility. In terms of stations, we have button stations that can be any number of buttons from 1 button all the way up to 8 buttons per single gang station. And of course you can go to 2 and 3 gang stations and multiply your options by 8. But it can be very typical to have a series of button stations backstage in the equipment rack. Sometimes they often duplicate what is programmed onto the touch screen so that users have hard button stations for this. The egress locations, so the doors into the auditorium for the audience, will often have a button station at each egress location, and this will allow for anyone to walk into a dark auditorium and turn the lights on without having to travel into the auditorium in the dark space. Those button stations could easily be 2 button stations, so you have one that turns the house lights on and one turns the house lights off. Some facilities like to have 3 and 4 buttons so that they can have house lights at full, house at half, house at a glow for projection, and house out. Others like to have more. It completely depends upon the needs of the space. We also have slider stations. These can be controlling individual circuits. They can be controlling zones of control, usually for house lights. They could be submasters and hold stage looks. So there are a number of things they can use. I would say the touch screens and the button stations are probably a little more popular these days than slider stations, but I do see a lot of slider stations go in at the stage equipment rack location. But again, it just depends upon the preference of the design. So this table is showing locations. So we have backstage. We've got one 10-inch touchscreen and it's located stage right. Backstage, we also have an 8-button station that is stage left. At the egress locations, there are 4 4-button stations. And in the lighting booth, there's one 10-inch touchscreen that is a portable unit. So theatrical control. Consoles are there for programming school events that require more than just the basic presets that are established on the architectural system. These are much more sophisticated control platforms and are used on plays, musicals, dance concerts, holiday performances, and any event that has a scripted environment that requires internal lighting changes. So proper setup, use, and training are paramount to the end user's success. Consoles are where a typical high school facility end user group is probably going to spend the majority of their time, and it's the easiest thing for them to get overwhelmed with. So we'll talk about training more toward the end of this presentation. So here in this table, it's just identifying the different school types. So we'll start with an elementary school. Let's say we have a cafetorium or a proscenium. So the system level is probably pretty simple. as well as the user level. They're not going to have a lot of experience. So in this particular case, we put on a Strand 200 Plus console. It's a simple one or two scene slider preset console with some basic memory, but again, very individual, very simple, limited control. It is not uncommon for us to see jobs that are cafetoriums that don't have a theatrical control at all. This could be a small, simple contact relay cabinet, DMX distribution out to a small number of button stations, so and possibly a touchscreen. So it can start with it can be a very simple scale for these simple jobs, and then just simply scale up depending upon the complexity of the job. So a middle school proscenium, I would say the system level is probably getting into being the mid-level, although the user level is still simple. And this is where new systems, jobs we have coming up, we would recommend our Neo Compact 10. Now this is a brand new console that will be released in Q2 of this year, 2020. It will be able to output 4 universes of DMX as a base and expandable up to 10. It's a simple 19-inch console with a 7-inch touchscreen with 10 programmable faders on it. It does have buttons in order to do command lines. So this is where it differs from a lot of the other entry-level console offering. You don't have to deal with sliders and navigate touch screens unnecessarily if you don't want to. If you want to just bring up some lights and say record Q1 enter, as we've been doing in the theater for decades, you'll be able to do that on this desk. So again, that should be out Q2. At the high school level, typically with a proscenium, this is a higher level for the system. User level can vary a lot. You're probably going to have some very simple users, which could be some of the faculty that they just do not have a lot of experience or time or inclination to learn about lighting technology, but they may have students that they can get involved with that are happy to geek out like a lot of us do. So there's a wide range in user level, and here we'd probably drop in a full-blown Neo console. And then there are some high schools that may have a second performance space, a black box. So mid to high level with again a variety of user needs, and dropping in a Neo Compact 10 makes a lot of sense because they both run the same software and are on the same platform. So lighting positions will determine the lighting angle and help understand how to best light the school's auditorium. So we're going to look at some basic angles because in my conversation with a lot of the specifiers and engineers, they don't have a lot of this basic design background. So hopefully this will help. So most spaces are going to have some sort of a front of house position. This could be a cove where the structure is built into the facility. The location gets access from the ceiling. Staff can walk up there and gain access to all the fixtures. Other times this may be hung below the ceiling, either with limited access or a motorized position where the position can come down to the user. Too often it's a fixed position and requires scaffolding and lifts to get up to, which is expensive, resource heavy, and not very convenient. So this layout, which can be very typical for a school, shows complementary angles of the front light coming from front left and front right at approximately 45 degrees from center. This is going to fill in the shadows better than light coming in from straight on the front. Now, box booms. You may find, I find a wide variety of availability of these box boom positions in different schools. There are some that have no box boom position at all. There are some that have one per side, some that have two per side. Occasionally I see them that have three per side. But this is the perfect opportunity to understand what they need for a pit. And great angle to be able to light the pit from. It creates side light for the pit, which creates greater dimensionality to the performer and greater realism. And this is very helpful for orchestra and choir performances. I hear a lot of people dealing with schools tell me the one thing that doesn't seem to get solved as often as it should is lighting for the pit. So next would be the apron focus. Now again, this is where the box booms are extremely useful. They can cover the apron better than the overhead electric. They also give much better dimensionality to the performer when downstage at the proscenium, and it also allows this to feather in much better with overhead side light from the overhead electrics behind the proscenium. So speaking of that, here we have overhead side light. Some people call these pipe ends or high sides. These provide dimensionality to the performer. It does not light the background, so you don't wind up washing out any backdrop or cyc to light the performer. And this is a very good angle for creating a sense of separation between the performer and the background. So downlighting. Overhead downlight creates separation. It creates a sense of theatricality and helps provide atmosphere when used in more dramatic colors. So this really gives the team a better opportunity to start introducing colors. Because it is coming from the back, you're going to see some of it in the air, you're going to see it on the floor, you're going to see it on the set, to really help establish time of day and mood. So overhead backlight. The only difference between top light and backlight is the top light's pretty much going to be focused straight down, where the downlight or the backlight's going to be focused from behind. So this creates greater separation between the performer and the background. It creates the illusion of greater distance between the performer and the scenery or the upstage cyc, because it's pulling out the performer. That rim of light around their shoulders and around their hair does create that additional separation, so it makes the stage feel deeper or more dimensional than it otherwise would be. Overhead cyc lighting provides evenly distributed light for backdrops and cycs. And again, this is all about providing more theatricality visually to the production. Now with automated luminaires, they provide flexibility and dynamic lighting states that no static fixture can match. These fixtures can refocus, dynamically move, change color, project images, change shapes and size. There's absolutely no greater theatrical tool at the school's disposal. Now that flexibility comes at a price, and that price is training on how to utilize and use these powerful tools. So fixture selection, that's going to start out with the fixture systems. So this table starts by listing out the systems. So we've got front light, we got pit side light, we got front of house side light, and all of the systems that we talked about have been listed. Then identify the lighting location. Front light is often broken up between your front of house code position, as well as putting some front light on the first electric, which is to light the far upstage area for performers. Here we've gone with the PL Profile 4s, which are engineered with more output for longer throws in the front of house position, and the smaller PL1 profile on that first electric. We've identified the quantity that are needed, and that's all this table is here to do, is to talk about your systems, lighting location, fixture choice, and quantity. And you'll see as we go down this list, the box boom, the side light are all profiles. So they all have hard edges, they all have shutters to give you the ability to add gobos. Then once we move to the downlight and the backlight, we do go to wash fixtures. In this case, for the cyc lights, we have linear strip products with great output for this application. And we have a small quantity of the automated luminaires using the VL2600 spot and the VL2600 profiles. The difference between the spot and the profiles, anything that has listed as a profile will have shutters, and the one with spot will not have shutters but have an additional gobo wheel. So let's talk for a moment about relay control. With LED fixtures, traditional dimmers cannot provide power to the units. These are little mini computers, and they do not need a dimmed circuit. And in fact, powering up LEDs on a dimmer, even if it's parked at full, can damage the fixtures over time. So relays are designed to provide power to the units. The relays can be configured many ways, but will likely want to be configured to be turned off when not in use and not left on 24/7. There are a lot of commissioning agents that prefer to have them configured by VisionNet only. That way they're not on the console. There's little risk of ever having to, turn all the lights out on the console or go to Q0 and have that inadvertently turn off relay power if you have it only programmed on the VisionNet side. There are people that do like to have them on the console so that they have more control. These are generally not right or wrong solutions or answers. They're just simply choices. If the console is desired to control it, then the recommendation is to configure the relays addresses to go to full automatically when the console is powered on, and to return to architecture control when the console is turned off. Otherwise, if it's on VisionNet only, then there would be a button configured on the VisionNet that just simply says fixture power, and if you want to control the lights, then you hit that button to turn them on. As long as power's there, you can control them with VisionNet or with the console, and when you're done, you can hit that button and turn them off. The downside is you have to remember to power the fixtures off before you leave the space. So, fixture mode and data distribution. This is often where I have seen a lot of folks really not understand the differences. They sort of think a fixture is a fixture and you put it up and control it. But there are options, and when you have options, you must have solutions. So looking at this table, we have our fixture system. So we have dimmers, relays, then we have the front lights, the box booms, pipe ends, and so on and so forth. In this particular case, as an example, we've got 48 dimmers, and they're going to need 48 addresses. Same thing for the relays. Again, they're going to need to be controlled as well. Then from there, we start with our fixture type, and we look at our front lights and say we've got our PL Profile 1 Mark IIs. We've got 20 of these guys. Now what mode do we want them to be in? Just taking the PL Profile 1 as an example, they have 3 modes of operation. There's a 5-channel mode, which is intensity, red, green, blue, white. There is a 9-channel mode. This is the 8-bit mode. And there's a 16-bit mode, which uses 15 addresses per unit. So it makes a big difference as to the number of addresses needed based upon the mode that they're in. So in this particular case, 20 fixtures, we're in the 5-channel mode, that's 100 addresses. And I'm sure you probably figured out by now if we had gone with the 16-bit mode just for those fixtures, it would be 300 addresses. It might be appropriate to say, well, what's the difference? Why would one choose a 5-channel mode over an 8-bit mode or a 16-bit mode? So I like to start out by finding the needs of the facility based upon the end user's use of it. A typical teacher likely doesn't have this technical background to identify the fixtures modes, nor do they really know the difference. So I like to just ask about the use of the space. And one of the first questions I ask is, do you ever need to perform a 10-minute sunrise during a theatrical production? Because if you need to do long, slow fades, you're probably going to need the extra resolution that 16-bit gives you. If it is not needed, then I like to keep it as simple as possible. In case of the PLs, you don't get any real benefit going to the 8-bit mode from the 5-channel mode unless you very specifically need the color preset channel or the strobe channel, or anything else it provides. So for me, it's generally a question of whether it should be in the 5-channel mode or the 16-bit mode. One of the other questions is when you have multiple cell fixtures like the SL640 strips, do you need individual control of each cell? It's great to be able to look at all of the dynamic eye candy that you can do with individual cell control, but I caution people from using it without really thinking it through, because if you have those 640 strips on your cyc and there is no direct view application because they're all up above borders, and so you can't see the front face of the units, the audience has no direct action, then you're certainly using up a lot of DMX channels for probably no reason at all. So you need to think about that. Our punch lights, the punch light 220s, they have 3 zones of control. But again, if they're not in the direct view environment, do you really need it? Because the difference in a basic control for an entire fixture of a 640 is 15 addresses, and if you're doing the individual cell control, you're now out to over 100 addresses at the 16-bit mode. So it makes a huge difference in the number of addresses needed. I have seen a lot of jobs where you get on site and you find out they do have these sorts of needs, but they can't utilize it because their system hasn't been engineered with enough universe control to distribute that properly. So it does make a big difference, and one never wants to go back and say, okay, we've got to do a change order to be able to put in the network distribution to make all of that happen, because the school districts, they don't want to deal with that. They've generally allocated and spent the money for the job and don't have the resources to re-engineer it. So anyway, it's very important to get these questions identified and answered as early in the process as possible, because you look down and add all this up, this tells us how many addresses are needed for the entire system, which tells us how many DMX universes are needed. I would say typically if it's a single universe system, our quotes and application engineering department are probably going to keep that all DMX distributed with no network involved. However, if there are multiple universes involved, we're probably going to engineer that with a network. So something to think about. So data protocol. This will determine what communication protocol is needed for communicating with the fixtures over VisionNet as well as over the theatrical console. Again, if it's cafetorium, everything may be able to handle on a single universe, and therefore there's no need for a network. But it is Cat5 cable is very much cheaper than DMX cable. And once the system is determined to be on the network, our DMX 512 nodes can communicate over a variety of protocols. We have ShowNet, ArtNet, Streaming ACN, and others are available, but not all protocols are available on the dimming relay product. So this is showing the system components, how we've got A21, and what control needs to communicate with the A21. Well, probably both VisionNet and the console. And again, I've just chosen ShowNet as an example here, but that could easily be Streaming ACN. So adding all this up and including the address count for your fixture package will let you know how many addresses and how many universes are required for that system. So commissioning. Commissioning is there to configure the system to function according to the specifications provided by the consultant or the specifier when the consultant is not involved. A consultant specification, the information is typically fairly clear and complete, but when a consultant is not involved, there may be a limited amount of information which to guide a commissioning agent. So the needs of the end user in combination with the commissioning agent's experience and standards will often drive the outcome of the system's functionality. We do see jobs where the commissioning agent will get on site and just not have a lot of direction for how that job needs to be commissioned. So they go off of their experience, and if the end users are involved and they can communicate openly about their needs, then that can help the process. But again, the goal is to have the information on these tables sort of pre-filled out and pre-collected and available to sort of hand over to the commissioning agent so that they have some direction with which to go by. They understand the modes that are needed and the fixtures ahead of time, and that will go a long way to simplifying that commissioning process. This table is to sort of go through and identify the user's needs. So again, when I talk with the end user about making sure that 80% of their needs are covered by VisionNet. So I say in order to do that, we need to go through and identify the presets that are needed for your facility. House at full, house at half, house out. If there's a projection glow that we need, and then what lighting states do we need on stage? What type of events do we have? Assembly, there's a podium, choir, band, orchestra, classroom, performance, dance recital, right? Whatever it is, so that this can all be pre-recorded. Especially if touchscreens are involved, there's virtually an unlimited number of presets. I say virtually unlimited, but in this case, there's certainly plenty of headroom to program all of the presets are needed. Then with button stations, you just have to decide which ones you want to put on the button stations for quick access from other locations. System training is the final step in any new system to get the user trained on the function of the architectural system, the dimmer and relay system and its maintenance, and any fixture maintenance involved. So it's generally going through and identifying how the fixtures function, that they have a little screen on the back where you can see DMX addresses so that if fixtures are ever moved, that one understands that they're still going to communicate over that same address unless you choose to alter that. If that gets changed, then it has to be changed both on the commissioning file from VisionNet and on the console file. So it's not something to be done lightly. Console training. Starting about a year and a half ago, we started separating and adding console training into all console quotations on the systems. The reason for that is that the console training really needs to be separate from the system training so that the end user group is not overwhelmed with too much information in one session. Some console training sessions may be able to be conducted by the commissioning agent. which is likely appropriate for the simpler ones. On higher level facilities, it should be conducted by a factory console expert and called out separately in the specification. I often see schools that will set up training all in one day to try and make it convenient for the end users to schedule. However, these people are now being asked to train on their lighting system, the audio system, the AV and projector, rigging, fly system, and console, and they just get completely overwhelmed. It's just not appropriate to expect that they can handle all of this in one time. So we're directing separation of the system training with the console training so that it's on a separate day. When appropriate, it's done by a factory certified console expert. We're actually going to be moving to a certification program for factory training later this year so that this can be dedicated and directed. We all know that the more complete an end user's understanding is at the time of handover, the more successful they're going to be, the happier they're going to be, the less stress they're going to have, and the less need there is going to be for follow-up and managing problems and tech support down the road. So by putting the effort in up front, it's going to save money for everybody in the long run. So with the right guidelines, a school's auditorium lighting system can provide absolutely everything that the school needs for years to come and get us all a happy group of end users. Thanks for attending this training session. Please join us at strandlighting.com for more information on future online classes.